Hello everyone, welcome to this video. In the previous video, we learned about all the pins of 74HC595, which is the shift register. We saw that the power and the ground, they are connected to pin number 16 and 8. Also, we learned how the output goes from pin numbers 15, 1, 2, 3, 4, 5, 6, and 7, which is the parallel output, and the serial input is basically taken on pin number 14. Okay, in this video, I'm going to use this program. We have defined the data pin, latch pin, and clock pins as pin numbers 2, 3, and 4. This is what we did in the previous video. In the setup, we have set up all the pins as for output. In the loop, this is the part where I will be changing every time I change the pattern. I will be changing the pattern from here. Rest of the program will remain exactly the same. I have created a function called showLEDs function, which is taking a byte as an argument, and it is what it is doing is, first of all, it actually sets the latch low to let the data remain in the shift register. Okay, we are using the shiftout function here, where we have used b to be displayed. So after the shiftout happens, the latch pin is given a high. Now when it is given a high, that output now goes out of the pins, those parallel pins, and they are actually visible on the LEDs. Let me show you the working of this program. Here I have a variable b, which is stored binary. In binary, it is storing 10101010. So that means it is storing one LED on, one LED off, and so on and so forth. When it calls the showLED function, it actually, that byte is actually displayed. So let us start this simulation. This is not a pattern, but it's only a static thing. But you will see that the 10101010 has happened now. Now let me explain a few things to you first. I am going to use two functions called as bitSet function and bitClear function. BitSet function and bitClear function, both of them take two arguments. One is a variable which contains the bits, and n is supposed to be used for setting the nth bit or clearing the nth bit. So that means if I write var comma 0, it will set the 0th bit, and over here if I say var comma 0, it will clear the nth bit. Let me show it to you using an example. These are the bits. So we have bits 0, 1, 2, 3, 4, 5, 6, 7. Okay. When I have an int variable called var, which has a value of 0, once it is 0, it will contain all of them zeros. Okay. But when I execute the bitSet function with var comma 0, 0 is this bit, right? This bit. Okay. So this bit is actually now set as 1. So that means rest of the bits will remain 0, and this bit will actually become a 1. Now I make var is equal to 0 again, then that means all of them will be zeros. And then if I write bitSet var comma 1, it is going to set bit number 1. I have written the decimal values of these also, so you could use them if you wish, but this is just for reference. Alright, so that means whenever I write a bitSet function, so if I say bitSet var comma 4, it will actually set the bit number 4. So this is the bit number 4. That is what it is actually going to set. So that bit will be set as 1. Now bitClear does the opposite. BitClear is basically used to clear the bit. For example, I have the original value of t, which is 0, and this is 0. Okay, all of them are zeros. All right. So when I give the command bitset var comma 3, so bit number 3 is now set. So bit number 3 set. This is, you can see, bit number 3 set. Now, if I write bitset var comma 6, it will now set bit number 6 also. Now, I said also. Why? In the previous one, it was actually everything used to become zeros because we were running var is equal to 0 every time we wanted to set bitset. But now we are not setting t as 0 again. So the value of t remains. So that means this bit has been set. And if I set 6 also, 6 also will be set. Now if I set bit set var comma 7, it will set pin number 7 also. Now bit set var comma 1, it will set number 1 also. So that means you can see that if I'm using these zeros and ones to set the LEDs on or off, whatever bit I set, that LED is going to get on. Now, there is another function called bitClear. BitClear var comma 3 will actually clear the bit from position number 3. So you can see that this bit has been cleared. Similarly, bitClear var comma 6 will actually clear this one. I have lightened those cells. So you have seen what bitSet does. If you actually make the variable as 0 every time you bitset, they will become 0. So only that bit is going to reset. And if you are not going to make it 0 again, what is going to happen is it is going to set all of them. So bitset 3, 3 is set, 6, 6 is also set. So that means now 3 and set, both of them are set. 7, now 3, 6 and 7, all of them are set. So I hope that is clear to you. Let us now write a program to shift on LEDs one after another and starting from LED 0. So LED 0 is this one. Let's take this one as 0. So only one LED remains on at a time. So that means once this is going to be on, then next time this is going to be off, the next one is on. So that means next two will be off, then the third one will be on, and then the fourth one will only be on, then fifth one will only be on, and so on and so forth. How will we manage this? We actually managed this when we started off, right? We started off with this program only. So how are we going to do this? We have set var is equal to 0 every time, and let's say bit set 1, 0, var comma 0. So this one is set. So we say var is equal to 0 again. So that means all the bits are zeros. Then we say bit set var comma 1. So the first one is set. So the first LED is going to go off, the second LED is going to go on. Now let us program this now. You saw that we are using bit numbers 0, 1, 2, 3, 4, 5, 6, 7. So why don't we use a loop in which we create a variable called x which starts from 0 and goes up to 7 and is increased by 1 every time. We have created a variable called var which is outside the loop, and inside the loop before anything starts we make it as 0. So that means it is cleared every bit which has been set up. And then the first command that we give is bitset var comma x. Now var comma x is going to be 0 in the beginning. So this becomes bitset var comma 0. So this LED is going to go on. The rest of them will be off. So how is it going to be displayed? We will execute the show LEDs function. We'll just pass var to it and it will display the LEDs according to the bit pattern. Now, after a delay of 300 milliseconds, it goes back up again and x becomes 1. Var is 0 again. See, var is 0 again. So once var is 0, all the bits are 0 again. So once they are 0 and I say bit set var comma 1 now, this is actually going to set up this bit and the next LED is going to go on. Okay, what I'm going to do is I'm going to copy this program from here and pass it to my Arduino program. Okay, over here I will remove everything from the loop function and paste whatever I copied from there. and let us see how things happen, how it executes. So it starts from one side and goes to the end, and only one LED is on at a time. Let me give it a little more delay. So if I give it a more of a delay, let me give it a delay of 800, say. Then you can see this is set, then second is set, then third is set, then fourth is set, and so on and so forth. You can see the other LEDs become off. Why? Because all of them contain zeros. So if there are zeros, they are going to be low and the LEDs are not going to be switched on. This is from the other side now. So earlier we started off from one side, that is from this side. Now we are going to start from this side. So we will have uh, LED number 7 going on first, and then so that means it is the reverse direction. So this means in the variable, the pin number 7 is set first, then 6, then 5, and 4, and so on. So what do we do here? If I want the reverse, that means I want to go from the other side now. So I'll just change the loop now. In the loop, I'm starting with 7 and going up to 0. In the previous one, actually, I was starting from 0 and going up to 7. Now I will be going from 7 up to 0. So let us just copy this program from here. So I'll paste the program here and run it now. You will see that it is now doing from the other side. So that means it is now running from the other side. Let us see another pattern. Now there is some difference in this pattern. I'm switching off LEDs one at a time, starting from one side, but only one LED remains off at a time. That means all the LEDs are on at a particular time. So how do we manage this? When we want all of them to be off, we want all the bits to be off. So we just set one bit. Now what we are going to do is that we are going to set everything as on and we are going to clear one bit. So how do we do that? We create a variable called var which has a value of 255. Now 255 actually means all the bits of a byte are ones. You can do the calculation yourself. Now what I do in this program is that I make var 255 each time I want to clear. So every time I make 255, it is actually going to make all of them as ones. That means all of them are on. And when I give the bit clear command, it will clear one of them. Let us see the program for this. You can see that I am clearing bit number 7654321 and 0. So that means my loop again goes from 7 to 0. So I have put var is equal to 255 every time in the loop. That means whenever the loop executes, it will make all the bits as 1 and it is going to clear one of the bits. So that means in the first loop, it is going to clear pin number 7, clear bit number 7. So it has cleared bit number 7. When it goes to the next one, it clears bit number 6 and 5 and 4 and 3 and 2 and 1 and 0. So you can see the pattern over here, how it actually should be working. And let me copy this program. So if I paste this program into Sketch, let's see what happens now. Now all the LEDs are on and only one is off. And that off is actually moving from one side to another side. So that means there is a 0 moving from one side to another side. So how did we manage? We said x is equal to 7, x is greater than or equal to 0, x minus minus. Now we want to switch on LEDs one at a time from one side to another side and then back to the other side. And only one LED remains on at a time. So how do we do that? This means this is going to be something like this. This pattern is one. It goes from the left side. One is on at every point of time, and once it reaches one side, the other side it starts again going back to the previous one. So how do you think some things are happening? You can see that earlier we were actually going from 7 to 0 and then we started from 0 going on to 7. So that means I cannot do it in one loop, it has to be two loops. In fact, the two loops that I used in my previous programs, both of them are being used one after the other. Okay, so that means if I have created the first for loop like this, which goes from 7 to 0, and then another for loop over here, which goes from 0 to 7. Let us see how this works. I'll copy this from here and paste it here. You can see that goes from one to the other side and then back to the first. Then one side to another and then back to the first. What if I wanted all of this LEDs to be on and only one to be off? So when that kind of a situation is there, I need it to be on. So I will make it 255. Everything will be on. And instead of set, I will make it clear. So that means clear will be clear. That bit will be cleared. So if I do this, see what is going to happen if I change this now. If I run this, all the LEDs are on, but there is an off LED which is actually moving from the left side to right side and right side to left side. Many times we have LEDs going on from the center of the LED string to outside or outside going in. Okay, so over here this is outside going in. So that means the outermost LEDs are switched on first. Then that those pins go in and in and in and so on. So in the end, the middle two pins are being uh, switched on. LEDs are switched on. So what are we doing? We are actually doing parallelly at the same time. I'm switching on 0 and 7. Then I'm switching on 1 and 6. Then I'm switching on 2 and 5. Then I'm switching on 3 and 4. Rest of them are cleared. So for clearing them, I will make var is equal to 0 every time again, every time. Now I want 0 to 3 and 7 to 4 together. So how do we do that? You can see the colors over here. I've colored everything. So we have two variables called A and B. A is actually going from 0 to 3 and B is actually going from 7 to 4. So what do? We write only two semicolons in the for loop, but before the first semicolon, we we initialize both the variables as 0 and 7. This is what we are going to start off with. I have given one condition, and the condition is A is less than or equal to 3. Why have I not given B is greater than or equal to 4? Because both of them are actually working together. So if one condition fails, both are actually going to fail. What about the increment? I am increasing A because A has to increase from 0 to 3 and B is being decremented. B is actually being decreased from 7 to 4. And we give both the commands together. So when we give both the commands together, it actually clears A and clears B. So A is 0, B is 7, so both of them are cleared. Let us see the running of this program. Let me paste the program here and see how it works. So it is going starting from the outer and going in, outmost and then going in. The next one is innermost pair and going out. You can see that we are starting off with the 3 and 4 and then 3 and 4 and then 2 and 5 and then 1 and 6 and then 0 and 7. So that means now if I take this as A and take this as B, now A is decreasing and B is increasing. So how do we do that? Again, the same kind of loop that we used earlier. A starting with a 3, B starting with a 4. Yes, they are starting with 3 and 4. We keep on running this till A is greater than or equal to 0. So yes, it will go till 0. And A is decreased every time, B is increased every time. Rest of the commands inside the function are exactly the same as earlier. So when I copy this from here and paste it into the sketch, see what happens now. It is going from inside out, from inside out, from inside out. Okay. Uh, the next one is a little different. For example, this over here, these were switched off. All right. So if they were ones, they were switched off here. I don't want them to be switched off. So what do? I do not give this var is equal to 0 command again. All right. So the program remains the same. And if I don't give that command, I'm going to go to my previous program. And over here, if I just remove that var is equal to 0, what is going to happen? The LEDs are going to remain on. So this pattern is a little different from the other pattern. We have this in to out and out to in kind of a thing, both of them. So we actually use both of them now. Okay, so that means this is the loop for going from in to out, and this is out to in, and we just use both of them one after the other. And when we do this, see what happens. It is going from in to out and then out to in. Okay, in the next program, we are going to make an LED appear as if it is being pushed from the left side to the right side. So for example, over here, this is 1, it is actually pushed to this side. This 0 becomes a 1, it pushes this over here. Then this becomes 1, again this goes and comes over here, and this appears to push this one over here. I'll show you the program and then you can see how things are happening, and then I'll explain it to you. So it appears as if the LEDs on the left hand side are glowing. They are pushing one LED from one side to the other side. Okay. Let me show you how this is working. Actually, I have put an outer for loop. This outer for loop is basically used to move the one LED from one side to another side. So if I actually don't show you this LED, so the ones pushing will not be displayed. Let us display only one LED that actually moves from one side to another side. Okay. What the inner loop is actually going to do, this loop is basically starting from 0, going up to less than whatever is the position of the actual LED which you are actually going to push. It sets those bits and actually displays those LEDs. I'm going to make a delay more. For example, if I make it 500 and make it 500 here also, see how things are going to happen. This pushes, second, third push, 1, 2, 3, 4 push, 1, 2, 3, 4, 5 push, 1, 2, 3, 4, 5, 6, 7 push, and so on and so forth. You can see this program and see the working of this program and make changes and enjoy. So today we learned about patterns, creating patterns using 74HC595. Now you can try creating your own patterns. Uh, you can suggest patterns to me so that if you in my later videos I could explain them to you, or if you want a program, if you want to understand how does that pattern works, I can explain it to you. So if you like this video, you like and subscribe, and give me a comment on your favorite LED pattern. Which pattern did you like? And in the next video, we are actually going to do daisy chaining. That means using multiple 74HC595 registers, shift ICs. Thank you for watching. I'll see you in the next video.